Hello, everyone. Welcome to another session of Microsoft Zero to Hero. This is Saidal, and I'm so happy that I'm hosting another session, another interesting session that we are going to learn a lot of things from another amazing speaker. As usual, I'm so happy to see you. And if you are in the live session, welcome to this session. If you are checking the recorded session, hope you enjoy and learn a lot again from another speaker. As usual, I'm going to share my very simple presentation about the today's session. We have Markum today. He's going to talk about a very interesting topic about SQL Server. If you love everything about SQL or data or structured data, relational data, this is your session. You are going to learn many things around this specific topic, and also Lee is going to share a lot of good things with us based on his experience and also his knowledge. So with that said, if you want to connect us, we have unique handler at Microsoft Hero for all the social medias that we are using, or you can use hashtag Microsoft Zero to Hero, Microsoft Hero, to be able to either mention us or use our hashtags. Otherwise, microsofthero.com. Basically, it's our website. There is a QR code here actually that you can scan. You can get updates from the other sessions, the schedules that we have in our community, or even if you scroll all the way down, you can see how we can connect with us in Microsoft Tech Community, our LinkedIn accounts, or also YouTube channel. On YouTube channel, make sure that you are subscribed us. And also that ring bell is on, so you can get the notification from the latest videos or live sessions that we basically hosting on our community. Perfect. So as usual, I have my code of conducts before I bring our speakers into the stage. In Microsoft Zero to Hero community, we expect you to be aware of others, be friendly, and also be welcoming to and respectful to the questions and answer. Be open to all questions and viewpoints. Be understanding of differences, and be kind and considerate to others. With that said, and no wasting more time, I'm going to bring our amazing speaker, Lee. Hello, Lee. Welcome to our live sessions today.
Hello. Good morning. Nice to be here.
Thank you. Thanks so much. So, Lee, before we start your session, I have a question that I normally ask from all of the speakers. Why do you think Microsoft Learn is important, and why everyone needs to go through that, learn about documentations and reading from there?
Well, Microsoft Learn is important because it is a primary source of truth about how the product works and how features work. You get a good summary and a breakdown. There are lots of examples in Microsoft Learn about how to implement something, caveats, things to consider before and after you implement. So that's why I think Microsoft Learn is a critical resource.
Yeah. So with that said, we can say Microsoft Learn is fundamental of learning. So it's important to start from there, learn more, and then getting experts in a specific area. Good, good. Thank you so much for the answer. And then if you are ready, please share your screen, and then we can bring up your presentation, and then you can take over the session. Perfect. Good. So good luck and enjoy your. We are going to enjoy your session, and I'm in backstage if there is anything that you need. So good luck, man.
Okay. All right. Thank you. So welcome everyone. Today's session is going to be on modern SQL Server features that make life better, easier for you as a data technologist. So I really appreciate the community asking me to come, accepting this submission. A little bit about me. I have been in IT since about 2008 and have been a speaker in various roles in various conferences. Got started in New Stars of Data in 2021. Have done a variety of SQL Server meetups and some SQL Server SQL Saturday events as well. So it's a little bit about myself. I have a blog here. If you want to reach out to me, you can at leemarkum.com and LinkedIn as well. Enough about me. Let's dive in. So I want to set some expectations here on the presentation. The goal really is to introduce a lot of different features and get you started. It's to whet your appetite so that you get a sense of what's available in modern supported SQL Server. So I can't go in depth on those items. We're going to be covering too many things. Also, I'm going to be focusing on the database engine itself rather than the other great segments and products like integration services and so forth. There are a lot of features I could have chosen from. Again, I only have 1 hour to talk, so I have to pick and choose some things. If I left out your favorite feature or something you're really interested in, my apologies. We're going to talk about 4 general categories today. That's performance, troubleshooting, T-SQL, and then high availability and disaster recovery. We're going to go ahead and jump right into performance features and talk about modern performance features that give you practical wins. That first feature is lightweight query profiling. This has several iterations since it's come out initially. And what it does is it allows you to view query plan execution and progress from currently running queries. Before, when you wanted to see what was going on with a particular query, sometimes you often had to capture that query, copy paste it into a different SSMS window. Maybe you would run a estimated query plan, or you would go over to a lower environment and run it for real, get the actual execution, and gain some insight that way. Lightweight query profiling allows you to do that while the query is currently running in your live environment. So it speeds up the troubleshooting process and gives you a sense of what's happening with your system. One of the things I really love about this feature is that it can be used to see index creation progress, which wasn't really possible prior or was really difficult to do. And many of us probably have been asked by someone when we're going to make an index change, well, how long is that going to take? Or how far along is it? With lightweight query profiling, you can see the progress that's happening for any particular query, including index creation. So that's a lovely application that I think of this feature that's going to make your life better and give you some wins. As it's progressed, as the feature has progressed, it doesn't collect CPU runtime information. You do still see IO and total rows for each operator involved in whatever query it is that you're watching at the time. And the way that you see this information is through sys.dmexec query profiles. That came out in 2014, Service Pack 2. But as I mentioned, have been a lot of different enhancements and things over time since it was initially released. In 2016 Service Pack 1 and 2017, you can get this feature by using the trace flag 7412. In 2019 and forward, it is enabled by default, so you don't need the trace flag to get this feature and be able to use it. The next thing is seeing the last known good query plan. So the sys.dmexec query plan stats DMV allows you to see the last known actual plan for most queries. Again, without you having to rerun the query. You don't have to capture it and then go run it somewhere else to get this. You just need the plan handle for the query that you want to view that last known actual plan for. So it speeds along troubleshooting and helps you get information quicker. You can enable this globally, again, with a trace flag 2451. And also, this is a feature that you can turn off and on at the database level as well. If you just want to use this for specific databases, there is an alter database scope configuration that you can run for the database where you want to be able to see last known actual plans. We're going to talk a little bit here briefly about intelligent query processing. I say briefly, we're going to talk briefly about this particular slide. This is a collection of features, as you can see. It's not any one feature. And you can see it's color coded. You have 2017, 19, and 2022. So Microsoft has been working very hard to make changes to the database engine and to query processing so that performance can be improved without you necessarily having to do anything to the query itself in order to achieve that performance improvement. One of the first things that we're going to talk about, or the first thing we're going to talk about for intelligent query processing features, is memory grant feedback. Now, this became available in SQL Server 2017, and what it does is it monitors the use of memory for queries that run, and it can make adjustments either up or down to the memory grants that happen for queries. So when it sees a query that's spilled to disk, for example, because there wasn't enough memory granted to it, the next time it sees that query, it will then grant more memory to avoid that spill to disk. Conversely, if it sees that there was more memory granted than was used, maybe significantly more memory granted, then the next time it sees that query, it will actually lower the memory grant. And so this is just a nice feature that Microsoft has created to help memory management within the SQL Server environment. It does use the cached plans, and it updates and stores that memory grant feedback for the queries within the cached plans. And so in 2017, at least, it doesn't require or use query store. Now, this feature can, as I've described it, result in a zigzag effect where you get a lot of memory granted and then it lowers it and you go back and forth. When it finds queries that follow that particular pattern, it does disable itself for that particular scenario, so it doesn't just keep happening with this zigzag scenario. Since the memory grant feedback is stored in the plan cache, when you start or restart the SQL Server instance, or when you add a recompile to a query, then that feedback that it was storing is lost. You do need compatibility level 150 to get this for batch mode, and I'm sorry, 140 for batch mode and 150 for row mode. You can see the process of the memory grant feedback that it goes through in order to evaluate and make decisions using an extended event called memory grant updated by feedback. You can also see spill events using extended events through spilling report to memory grant feedback event. So there are ways to track and see this feature's effect on a particular query and or server. Now in 2022, this particular feature got an enhancement where it's persisted and it's a percentile memory grant feedback. So what that means is that for 2022, for this feature, you do need the query store. It doesn't store the memory grant feedback in the cache plan. It stores it inside the query store, which is capturing the performance in the queries that are running on your system. That query store does need to be, so it has to be enabled and it has to be in read-write mode. You do need compatibility level 140 and higher for your database in order for the persisted and percentile memory grant feedback to be available to you. You do get this feature in Azure SQL Database, and at least as of August 2024, it wasn't in managed instance, but it may be by now. That's the most recent information I can find about the availability for this particular feature in managed instance. So what does this look like in practice? So the zigzag that you see there are kind of what you would get with SQL Server 2017. You can see the actual needed and the last use granted, and the blue line shows the percentile granted. As you can see, it does tend to err on granting or allowing the grant of more memory versus less, and I think that's because Microsoft is looking to avoid that costly spill to disk that makes your query go so much slower. The next intelligent query processing feature we're going to talk about is called DOP feedback. That stands for degree of parallelism feedback. In order to get this feature or enable it, you have to have database compatibility level 160, and you do have to have the query store enabled and in read-write mode. So what does this feature do? Let's say you had a SQL Server with one NUMA node and 8 cores, and you set, let's go with 16, and you've set feedback, you've set max stop to 8, which would be the recommended best practice. So when a query goes parallel in that case, it's going to use 8 CPU or 8 threads to process that query. What DOP feedback does is it, based on internal algorithms, analyzes that query and decides that it's a good candidate for DOP feedback, and it's going to, the next time it sees that query, lower the number of cores that are used. So the next time it sees the query, it may lower the feedback to 6 or 4. And then it evaluates the performance of that query to see if the performance was relatively the same with less threads for parallelism. And it keeps making that adjustment. And once it hits a regression, in other words, it lowers it and says, oh, this doesn't perform as well as it did, then it realizes I need to use the next highest threshold that I use. Let's say it's 4. Then it persists 4 for that particular query as the correct degree of parallelism number to use. And it persists that using the query store. You can see this verification process and the verified feedback in the sys.querystore feedback catalog. This particular feature is actually on by default in SQL Server 2025. So I've mentioned Query Store a few times already, so let's talk about Query Store. Query Store came out in 2016, and to my surprise, there are still a lot of places that don't know about it at all, or they don't know very much, and they're just not using it. So Query Store is a wonderful thing that lets the system gather performance metrics for queries along with their plans, and has some other features that we're going to talk about. Now, before we get into those details, a lot of folks have said to me, that's great, but I'm a developer and I don't have access to production. Well, that doesn't mean that you can't take advantage of and see the information in Query Store. For folks who are non-admins, you can see the Query Store internal tables and run the built-in reports using the view database permission. So if you go to your admins and request this permission, you can access the Query Store information. And there's a link on the slide there that shows you what the schema of the internal Query Store tables are within that particular database. This is a per database feature, so you can turn it on gradually for databases that you want to do a targeted evaluation, not only of Query Store, but of a particular database and application that might be having an issue. You can turn it on just for that one and see what you get back. So part of what you're going to get is this aggregation of runtime performance. And you can see a number of metrics. These are not all of them. You can see a number of metrics on the slides, things like duration and physical reads, degree of parallelism, memory consumption. And across the plans and queries that it collects, you can see the average, max, min, and other ways to slice this information. So it gives you a pretty good picture of what your query performance is like. Now in 2017, SQL Server 2017, they added weight stats collection. So now when queries run, it captures what was this query waiting on. And there are weight categories that you can see inside a particular report. So for example, there is a category for IO. So you can click into that category and see what queries are affected by I/O. Particularly, maybe they're waiting on data to be read from storage up into memory so that they can continue processing. And there are other categories that you can see as well. The product continued to evolve and got another feature, which was called custom capture policies in SQL Server 2019. And this allows you to better control what's actually being captured by Query Store. So you could set filters for things like CPU time. So a query has to accumulate and use a certain amount of CPU before Query Store would actually capture this. And again, this is just a way for you as a data technologist to have more control over the performance of Query Store, what it is and is not capturing. Another great thing about Query Store is that you can apply query hints without actually changing the code. This was available in SQL Server 2022. So for those off-the-shelf products that your company has purchased, you're using, when there are issues with the code or things that are detected performance-wise that could be improved, but you can't get the application vendor to address those, then you can use Query Store to apply query hints without ever changing the application code. So it's a wonderful way to be able to adjust performance or to address performance issues in scenarios where you can't change the code. Another thing that Query Store lets you do is compare two plans to each other side by side. So in the graphing that Query Store provides, you can see the number of plans that any particular query would have. And if there's a query that has 5, 10 different plans, you can look and see which ones seem to perform best and then compare that to some of the other plans. And you can look side by side and see what is different between these particular query plans and get insight into how the database engine is processing the data and processing in order to get the data for that particular query. It does track and can track the stored procedures performance over time. It uses a unique query ID inside the query store in order to do that. And I do want to mention one thing that's and explain one thing that's on the slide, assuming no one drops and recreates the procedure. So if when you make changes or when your company make changes to a stored procedure, if they don't use alter, but they drop and recreate, then the next time that query runs, Query Store is actually going to assign it a different query ID because it thinks it's different. When you drop a stored procedure and then recreate it, the system object ID associated with that stored procedure changes. So if you can, we try to avoid drop and create and just use alter procedure when you're going to change stored procedures, because that keeps the query ID and system object ID the same and allows you to track a single stored procedure's performance over time by the query ID in a particular report that's inside of Query Store. Query Store also has a report for regression, and you can also use it to force good query plans. So if you're having a performance issue and you see that a particular statement or procedure has a number of query plans and some of them maybe don't perform as well as others, you can force a particular plan and then and that should be a temporary fix, and then you have some time to go back to developers and say, how can we adjust this query, what can we do here to make this query so that it gets a more stable and regular and consistent plan. Forcing the plan doesn't always work 100%. There are some reasons why even after you use this feature a query might not use the force plan, but for the most part you get a good benefit of a stable plan when you're using that force feature. Some of the reports that are in Query Store shown here on the screen. The ones with asterisks are the ones that I tend to use the most frequently. So top resource consuming queries, there's that one for weight statistics that I talked about, and then tracked queries that I mentioned when I talked about tracking a stored procedures performance over time. A couple of important trace flags are 7745 and 7752. These kind of do opposite things for opposite problems. 7745 will prevent Query Store from trying to write its data down to the disk before a shutdown happens. I have noticed that unless something has changed in the last year, that this trace flag is not available on AWS RDS in case you happen to be using that and have the Query Store turned on. 7752 enables Query Store to load data into memory asynchronously. And so what this does is Query Store without this will prevent queries from running in that particular database until its metadata has loaded. And so 7752 addresses this. If you're on SQL Server 2019 and above, you don't need this trace flag anymore. Query Store is wonderful for use before and after migrations. One of the things I have done is if for some reason Query Store was not turned on and I knew I was going to migrate databases from one server to a new one, I get an upgrade, I would be sure to turn on Query Store at least 2 weeks before the upgrade migration date. So you could collect information about how is performance right now. And then you do the migration. When you restore databases, the Query Store is restored in the same state that it was on the source. And so when you come up live on a new system, it again collects information and you get this before and after picture that you can see not only from the reports, but you can actually query some of those internal tables I mentioned and do a comparison yourself to see how individual queries performed both before and after a particular upgrade. So as you can see, Query Store has a lot of tie-ins to features, and we've talked about some of those tie-ins in SQL Server 2022 and Intelligent Query Processing. For SQL Server 2025, which was just released and went generally available this week. One of the really interesting things is that you now get a standard developer edition. And so what you can do is you install standard edition version of developer edition. So you get the developer edition licensing with standard edition. And like, but why would that be important? Well, because a lot of folks use developer edition in non-production as they should, but the developers don't always know, folks don't always know which features are standard edition versus enterprise edition. And they might develop an app that relies on a feature in developer edition that doesn't exist in their production because production is standard edition. So having this ability to install a standard edition of developer prevents that scenario. Another thing that as a performance feature that's going to make life better and easier for you and give you some practical wins in SQL Server 2025, the resource governor is now available in standard edition. And as part of that, you get the TempDB resource governor. And I really think this is going to be a game changer in a lot of ways. So what does this actually do? You can, with TempDB resource governance, enforce a limit on the total amount of TempDB space that's consumed by a resource governor workload. So what you do is you can assign a query to a workload group. Let's say it's reporting, for example. Maybe you're running Power BI and you have a service account that runs all the Power BI queries. You assign that service account to a workload group. Then that workload group has a limit on the amount of TempDB resources that it can use. When that query attempts to exceed the limit for the workload group, Resource Governor will actually abort that query and give you a very distinct error so that you know why the query died or was killed. And it's there on the slide. We have could not allocate a new page for database tempdb because that would exceed the limit set for workload group and then the workload group name. It's a very easy way to see and follow up on what happened to a query. The next morning you might be questioned about why the report didn't run last night, or that it ran for a while but then stopped. This particular feature allows you to see this error message and you know what happened. Then you can go back and say, well, we're using too many TempDB resources. What can we do to address that? Or maybe make adjustments in the workload group so that it can use more. But this is just a way to protect workloads from um, other workloads that might be using up too many resources. So you could set a higher limit for the default workload group that's used by your mission critical applications, your OLTP system that has to use all the time. Set lower limits for custom workload groups for things like reporting. Another performance feature that's coming to us in SQL Server 2025 is you get 256 gigabytes of RAM now. There used to be a limit of 128, and Microsoft has increased that limit in SQL Server Standard Edition so that you can handle larger workloads. And you also have an increase in the number of cores from 24 to 32 that you could use on SQL Server Standard Edition. Troubleshooting features. Let's talk a little bit about what we get that's new in modern SQL Server features that's going to uh, make your life better and easier. So many folks have seen this message: string or binary data will be truncated, the statement has been terminated. And that's the only error message you get. Now, all you know from, let's say, a SQL agent job is that there was a string or something was too long and it wouldn't go into the table. That doesn't really help you know what table, what piece of data. It just tells you something went wrong. And you can recreate this with this particular um, table demo that I have here on the slide. However, with SQL Server 2019 and above, you get a more complete message. It tells you what table experienced this problem and even the column name and the truncated values. So you get all the information right up front to help you troubleshoot why the SQL agent job failed or why some other part of an application didn't work. You can turn this on in SQL Server 2017 using the trace flag 460. It's available in compat level 150 and above by default. We're going to talk about temporal tables as that next troubleshooting feature in modern SQL Server versions that's going to make your life easier and better and give you some practical wins. Temporal tables or system version tables are composed of what I'm calling the current normal table that you already love and know in your database, and you get a history table. There is a special time range of start and end that are added to both tables. Now there is a way to hide those columns so that if someone's doing select star from your table, they don't get those new uh, time start and time end columns back in their result set. But it uses that to know the history of particular rows for that table. And one requirement for this is that the temporal table or current table must have a primary key. This can be a replacement for things like triggers and as a means of tracking changes to tables. What it doesn't tell you is who made the change. And there is a way of doing that though when if you look at a blog post by like Aaron Bertrand, he gives you a solution for kind of marrying those two pieces of information together. There is a all-in-one feature called Ledger feature that gives you the ability to track not only what changed but who, and that came out in SQL Server 2022. I'm not going to be covering that in this presentation. Again, this feature can help you answer what happened to the data and when, and it makes it useful for auditing, and you can also use it to run queries to show trends over time. So for example, maybe sales data or purchasing data. You can see how prices and sales for a particular product maybe trended over time. One of the first things I thought of when this feature came out is, wow, we could use this to fix what's commonly called those oops deletes, where people make a mistake and they forget the where clause in their delete, or the where clause is wrong, or they make some other update change that they didn't intend to make. Um, you can use the history table to see what rows were in the table at any particular point in time, and then use those rows to find the records that you need to restore back to your source table. This also is a way to help you help you avoid having to fix data by pulling down maybe a backup from Azure Blob Storage, and that database, maybe it's 2, 3, 4 terabytes, and it's going to take a while to pull it down. It's going to take a while to restore it. In the meantime, your data isn't fixed yet, but if you had this particular feature enabled, you could again use the history table to find the records and put them back. So it can save a lot of time that way. I've also seen this used as a replacement for change data capture, because it tracks and has information for inserts, updates, and deletes. So here is an example of a temporal or system version table. This is AdventureWorks. You can see that in this example, the product price was increased by 10% 2 times. Now, maybe someone only meant to do this once, but this shows you the records as they were when the changes happened at the time of the transaction started. So on January 18th, 2024, that top row there, that particular product ID of 822 had a list price of $549.83. And then it changed again, and its price was $604.81 and some change. So you could, if that second change was a mistake, you could use those first 4 or 5 rows to query those rows and put that data back into your source table. And again, if this was an intended change, maybe your price is really going up, then you could use this to track the rate of change in your prices. Let's talk a little bit about T-SQL enhancements. There are quite a number of features, T-SQL features in modern SQL Server that can help you. You have inline specification for clustered indexes and non-clustered, drop if exists, and create or alter. And again, we've already talked a little bit about how create or alter can be important for query store. We're going to look at, first I'm just going to briefly say that if you're using JSON or thinking of using JSON, there's a lot of JSON support for T-SQL for SQL Server, a lot more than I actually realized, and they continue to enhance that even in SQL Server 2025. Here are some more features. You have an optimized SP execute SQL. There's an alter table, and there are a variety of new string functions that we're also going to look at an example for. So here we're gonna talk about some examples of the inline index creation. So if you're building an application, you're building some tables, and you kind of already have an idea of what columns might be key to index, you can actually do this inline right when you create the table and skip the long create index syntax that you would need for after you've already made the table. So this is just an example of a filtered index. You can see you have, it just says column 1 int, and then your index definition. It just says index and the index name, the column, in this case where, because I'm using this as a filtered index. Here's a multi-column non-clustered index. Again, the syntax is simple. It's just index, the name of the index, and then your columns. You can do this as a unique non-clustered index and as well a unique clustered index, all right there when you're making the table. And you can also see in this example that I'm demoing how to use this drop table if exists feature as well, so that you don't have to write a bunch of T-SQL to see if a table exists before you make it or before you drop it. Now, concatenation. I have 3 different ways that concatenation can work that are there on the slide, and they are left justified so that you can see not only is it less characters, but beyond that, just looking at the lines, you can see that as you go down from the select to concat underscore WS, which means with separator, there's just a lot less. Not only is there less typing, but there's a lot less that you're going to have to do with your fingers on the keyboard in order to find the characters that you need in order to do the concatenation. And so this, not only is the syntax smoother, but it just saves you keystrokes and time trying to get strings to be concatenated together. And the output looks the same no matter which of those 3 methods you use. So I think it's a great win for developers to have to type less and do less keyboard manipulation in order to get the same result. Here are some other SQL Server 2022 enhancements for T-SQL, and we're going to look at the greatest and least functions as examples of what you can do with modern SQL Server T-SQL features. So this greatest and least, these are max and min functions across columns instead of rows. So let's suppose that you have a platform that allows customers to email or to manage their email subscriptions to a newsletter. And that customer wants to know, hey, what they want to know what their best and worst performing months were for people opening the newsletter. And so how you could do that is you could create a table that looks something like this, where you have a year and an integer value, and then you have your 12 months, and each integer value for your months is the number of emails that were opened. You could insert some rows, just like this. I just did 2 years as a demo. So here's what you could do with a case statement. This case statement only does a comparison for 3 months, not 12. And you could see that that's a lot to type to get the information about greatest and least. You could make it a little simpler by doing something like this with a cross apply, where you get the year and then the monthly total in the subquery, and then select the best and worst month using max and min over that monthly total. That's a little better, but what if you could just type this? Select year, best month equals the greatest value from January, February, March. The worst month equals the least value from January, February, March. That's a lot less typing to get good results. There are a couple of links to other demos of this particular feature. I have seen performance comparisons where greatest and least aren't good to use in where clauses, but if you were doing something like this, it could work out pretty well for you from a performance perspective. And again, a lot less typing to get the same information out. High availability and disaster recovery. So what I'm going to do here is just talk briefly about some of the limitations of features that we know and love. This is in no way meant to say we shouldn't use these features. It's meant as a way to compare them to a feature we're going to talk about later. So log shipping, the readable secondary that's in standby mode means you can't really, the data in there isn't up to date. So um, if you need real-time reporting, for example, then you either have to live with being a little bit behind or you have to find something else. There's no native single built-in connection name. So a logship secondary name, obviously you have to connect to that with a different name than you would to the primary system. Log shipping is configured for a single database. So if you have 50 databases and you want to log ship them all, you have to do them for each database. Database mirroring is similar or has some similar restrictions in that secondaries by themselves, in and of themselves, are not readable. You can take database snapshots of mirrored databases on the secondary. Snapshots have their own limitations, though, that make managing them not bad or wrong, but you just have to remember there's some things to think about managing database snapshots. And again, like log shipping, database mirroring is configured at the individual database level. Transactional replication has been around a long time. In order to use this, though, there are a lot of moving parts, and you kind of have to love SQL agent jobs. So that's some parts of difficulty or challenges with transactional replication. You do need a primary key on every table that you plan to replicate. And this is really the showstopper that I have seen if people are planning or thinking about using this to replicate entire databases um, for high availability or for disaster recovery, really. Uh, Many times you just find that your database has tables that don't have primary keys. And so right away, you can't use transactional replication, or you have to try to get those tables changed so that they do have a primary key, and that's not always an easy thing to do. Again, there's no single built-in connection name for the application. If you want to connect to and read the secondary or the target for a transaction replication, the subscriber, then you have to connect to a different name. Snapshots can be a bit intensive as well to get transactional replication started, although you can do a backup and restore to seed as well. Failover clustering is a wonderful high availability feature. It does require shared storage, and sometimes that can be a no-go depending on what virtualization features you might be using or other technology restrictions that you might have. To use it for disaster recovery, you need things like um, some kind of block level replication software like SIOS Datakeeper or those sorts of things. So to get that DR, you're going to have to go outside the failover clustering feature within itself. So how does this compare to availability groups? Availability groups came along in SQL Server 2012. There have been a lot of enhancements all the way through SQL Server 2025. With availability groups, you don't have shared storage or any kind of shared storage trickery via software, and that kind of addresses the failover cluster instance obstacle. On the other side of that argument, though, is shared because there's no shared storage, it means that you're using double the storage. Or if you have one primary and one secondary, it's double. The more secondaries you add, the more storage you're obviously using. It does provide disaster recovery via built-in data synchronization and multi-subnet configuration. So this solves some of the issues with failover cluster instances, although you can do multi-subnet failover cluster instances. There's no built-in data synchronization to an off-site location. One of the fabulous things about availability groups is that you don't need a primary key in order to set up availability groups. So that solves an obstacle that you have with replication. There is a built-in connection name for failover, which is called the availability group listener. And that kind of solves one of the issues with log shipping and replication of not having that connection name. Data is within a few seconds of the primary, which solves the issue with log shipping. I did read recently a very thoughtful post about how this can actually be problem, but and the problem that they posed is if you have an oops delete or a change happens in the data that was unintended, it does get migrated or replicated, synchronized within a few seconds. And so that's a problem. Yes, but high availability and disaster recovery solutions like availability groups or other things aren't meant to solve that problem. They're meant to solve a different kind of high availability and disaster recovery problem. But we will circle back to this idea here in another slide or two. You get readable secondaries at any time that you can connect to and read data from. And this solves or addresses the limitation that you have with mirroring and with log shipping. You also get readable secondaries at any time by using a read-only routing feature via the listener. So instead of connecting directly to the secondary using that secondary's name, with this read-only routing feature, you can actually point your read-only workload at the same listener that your OLTP system is using. And behind the scenes with an application connection string change in the read-only routing, the availability group will route read-only queries to the secondary for processing over there. You do get built-in automatic failover for not single databases, but entire groups of databases. And so this solves the issue of mirroring and log shipping, even replication, where it's a by database feature. Availability groups covers all the databases inside that availability group. They are relatively easy, I feel like, to leverage for upgrades. Not that the other features aren't, specifically log shipping, but you could do something like this. If you had a 2-node 2017 availability group and you wanted to go up to SQL Server 2022, or you're brave and you want to go all the way up to SQL Server 2025, you want to get the greatest and latest cutting edge things right now, what you could do is build 2 SQL Server 2022 or 2025 instances. You add them to your existing availability group as secondaries. Then at the proper cutover time, you could fail over to one of those new SQL Server nodes that you made. That completes your upgrade process. Now you're live on the new system. Then you remove databases from your old secondaries out of the availability group. You remove those nodes from the clustering, and now you're left with the 2 new nodes that you had for your upgrade. So that's one process that you could use using availability groups to do upgrades. There is also the distributed availability group method as well. You get automatic page repairs under certain conditions for secondaries or from a secondary. You get the ability to manage objects outside the database with SQL Server 2022 and above using a feature called contained availability groups that will manage things like your logins and jobs and those sorts of things for you. So one thing that you do need to think about before you use availability groups is that you do need the proper team members with the proper knowledge. They are more complex than doing something like log shipping or even replication because you need multiple team members involved who understand more technologies. You need multiple people who understand Windows clustering really well. You need multiple DBAs who understand the availability group components very well. And you also need subject matter experts who understand and can handle your networking element very well. The other thing that you need to think about is if you're going to use IaaS, VMs in the cloud, whether that's regardless of what cloud, you need to understand the cloud provider's requirements because there are some specific things that you have to watch out for in availability groups in an IaaS situation that you don't really necessarily have to think about if you're doing it on-prem. So backups and tested restore processes are your ultimate HADR solution. And this circles back to the post I was mentioning earlier when I was talking about how availability groups synchronize data very quickly. If you're trying to solve for what happens to my data when an oops delete happens or some catastrophic issue with data manipulation, log shipping, replication, mirroring, all of these other different kinds of technologies don't help you with that. Backups and tested restore processes do. So just keep in mind, none of this replaces having backups and testing that you can restore, that you personally know how to restore them, and that those backups actually can restore, that they're not corrupted in some way. Accelerated database recovery. So this is a wonderful new feature in HANDR that allows a redesigned recovery process to enable databases to recover much, much faster. It uses a new S-log or secondary log where it keeps um, versions of rows that have been changed in that S-log, and it can see what those row versions are. And if it needs to roll back, let's say, excuse me, during a system reboot because you've done Windows patching, but you had a lot of transactions going on, the secondary log can do a logical revert to what those rows were for mid-flight transactions. And that's much faster than having to use the older previous way of uh, transaction, reading serially through the transaction log to determine which things to redo, which things to roll back or roll forward. This feature is off by default, just so you are aware. We did get it in SQL Server 2019, but it's off by default. So if you're trying to make a change like this, for example, let's say you have a bunch of email addresses and a tested script, a script that was tested in development is running in production now, and it's taking forever and ever and ever, much longer than you're anticipating, and someone wants to restart the SQL Server to essentially stop the transaction and do what they think is going to be quick rollback. Without this feature, it's not going to be a quick rollback. With this feature, it will be a quick rollback and you'll get back into a consistent state very rapidly. So I really like accelerated database recovery. It has, in my experience, directly saved recovery times after patching anywhere from 15 to as much as 30 minutes in some cases. I had databases recovering that long before I used this accelerated database recovery. So how can you find out about new SQL Server features? There are lots of ways. Here are some links here that can give you some information about where to find new SQL Server features. MS SQL Tips is a wonderful place. Obviously, MS Learn is a wonderful place. That bottom link, what's new in SQL Server 2025 preview, that's I believe a Microsoft Learn link as well. Here's some bonus materials, some things that are really unique and interesting features that exist in modern SQL Server versions that can solve problems for you that, again, I don't have time or didn't have time to talk about. So if you're interested in one of these, just know I do recognize that those features exist and that you can do some really fun and good things with them. And I really appreciate you coming to this particular presentation on modern SQL Server features that make life better to give you some practical wins. Let me know if you have any questions, and here's my contact information.
Amazing. Thank you so much, Lee. It was really great. I learned a lot based on the information that you shared with us, valuable experience. And it was so nice. Thank you so much. And I haven't seen any questions so far. So we can stay like more than about 2 minutes more, see if there is any questions from audience. But if you want to connect to Lee, make sure that you are following him on LinkedIn or other platforms. or reach out him directly. So if you have any questions, so he will answer your questions. Good. Yeah. Since we don't have any questions here, but some thank you to you, Lee, based on the comments that I've got here. And then basically, yeah, I think we can wrap up this session. Perfect. Then thank you again. It was so nice, and hope to see you again on Microsoft Hero stage for next year. But it was really great. We learned a lot about SQL Server and, let's say, modern SQL Server.
Yes, thanks for having me. I appreciate it.
Perfect. Then thank you. Have a great weekend, everyone, and see you next session next week. Another stay with Microsoft Hero. Take care. Have a good one. Bye-bye.